Alright guys, today we're going to talk about the 113 notes, and if you want to follow along in your book, and we're going to be skipping all over the place because I just want to focus on these four things today. But we're going to start on page 39, but again, I'm going to be skipping all over the place, so you might be hard to follow. You may have to hit pause a few times. The first thing we're going to focus on is a relation a function, yes or no? And I know right now you don't know what a relation is or a function is, but we'll get to all that here in just a minute. But that's the first thing we're going to focus on is I'm going to put a situation in front of you and you're going to say, is this a function, yes or no? The second thing is function notation, and then absolute maximum and minimums of graphs. And then you're going to tell me if a graph is increasing, decreasing, or if it's increasing then decreasing, or decreasing then increasing. But we're going to be able to read a graph and use words like increasing and decreasing. But these are the four things that by the end of this video, hopefully you will be able to do and understand fully. All right, before we get into the definition of what a relation is and what a function is, I just want to have a decent understanding before we get into it. That way the definitions don't confuse you too much. I'm going to put a situation in front of you and it's going to be a relation. Our question is it a function or not? Because not all relations are functions. For instance, over here to the right, not all dogs are puppies, but all puppies are dogs. And the same thing over here. All functions are relations, but not all relations are functions. For instance, this little X right here, it's in the area for the dogs, but it is not a puppy. So that's like a grown Rottweiler or something like that. Over here, that little situation in red, it is a relation, but it is not a function. If I put a little blue X right there, that is a function, and that is also a relation. And if I put a blue X over here, that area right there, it is a puppy, which is also a dog. So today, before we get into the definitions of relations and functions, I just want to try to keep that straight to you visually. All right, on page 41, we're going to talk about relations. The definition over here is highlighted in green. A relation is the mapping between a set of inputs and called the domain and outputs called the range. So anything that you can match up, hey, this X goes with this Y, that is a relation. Now again, some relations are special, they're called functions. So we're going to look at all these little examples real quickly, and you can tell these are all relations. For instance, ordered pairs. This X, -2, is matched up with this Y, or output, +2. So because they're matched up like this, that is a relation. The equation to the right, if I were to graph it, it would be, well, let me make it a little better. It would start at -1, it would go up 2 and over 3. So we would make a line something like this, and every point on here could be matched up with an ordered pair. So therefore that line would be considered a relation because I can match up an X and a Y. The verbal statement, relationship between students in your school each day and their birthday, each student can be matched up with a birthday. So anything that can be matched up is considered a relation. If you look at the other three examples, you can see the mapping. We have this X value of 1 is matched up to this 2. This 4 is matched up to 5. 4 is also matched up to -5. And this 2 is matched up to 0. So again, all of these are relations. But now here in a second, we're going to start talking about special relations called functions. All right, on page 42 at the very top, you can see I have highlighted in green the definition of function. A function is a relation that assigns each element of the domain exactly one element of the range. Functions can be represented in a number of ways. Now, that's kind of a complicated definition, so we're going to try to simple this down, and I'm even going to try to give you an example to help you remember it. Okay, so to determine if a relation is in fact a function, it has to have, and I have right here number 1, every X value can only have one Y value. And again, I have a little situation I'm going to try to give you to help you understand that. But every X value can only have one Y value. Now, if you're looking at a graph, we're going to use something called the vertical line test, which is the exact same thing as number 1, only visually it is much easier to understand. So again, if a relation is a function, every X can only have one Y. And if it's a graph, we're going to use the vertical line test. All right, now I skip down to page 45. We have some examples of relations here. we're going to try to figure out, are these in fact functions? And you're going to have to do this on your homework, so make sure you pay attention and understand this part. Now on number 8, part A says, is y equals 3 raised to the x a function? And I went over to Desmos.com and I graphed this. Now I know you guys are supposed to have graphing calculators, but I can't really count on you guys understanding how to do that. We're going to spend a lot of time in person working with your graphing calculators, but for right now, Desmos.com is very easy to understand, and I would trust that you guys will be able to figure it out. So I'm going to type in y equals 3 raised to the x on Desmos.com, and I went ahead and screenshot that, and I have it right here. Now remember, there's 2 ways to determine if it's a function, and if it's a graph, we use what's called the vertical line test, which means if I can draw a vertical line and I hit the red line once and only once, that's okay. That would mean it's a function. But if I can ever draw a vertical line and hit twice, that means it is not a function. So I drew one vertical line right there in green. It only hit once. If I draw it anywhere, each vertical line will only hit once. I will never be able to draw a vertical, well, my vertical lines are getting kind of bad here, but I will never be able to draw a vertical line and hit twice. So therefore, this is considered a function because I could only draw a vertical line and hit once. If I ever drew a vertical line and hit twice, it would not be a function. And I want to give you a quick example of that. So, if I had this graph, see, I could draw a vertical line right here, and it would hit the blue line twice. So therefore, this would not be a function. It would be considered a relation, but it is not a special relation called a function. All right, for B up here, for every house, there is one and only one street address. Now remember, our rule is for every X, there can only be exactly one Y. Well, for every house, there can only be one street address. So that matches up. So this situation would be a function. That relation would be a function. All right, now let's look down here at C. Every X can only have one Y, and this is something I explain in person because I have a lot of kids that struggle to remember every X can only be with one Y, so I always give them a situation and try not to laugh at this, but I always say every guy can only date one girl. And I always write on the board, the domains are your guys and your range are your girls, and every guy can only go on a date with one girl. Now that does not, we're not trying to get into any situation like, well, what about this? We're not worried about it. I'm just trying to get you to understand that every X can only match up with one Y. So every guy can only match up with one girl. So if I look at this, this guy, -1, went on a date with this girl named 4. That's okay. This guy named 0 went on a date with a girl also named 0. But if I look down here, this guy named 0, he's also right here. So this guy 0, he went on a date with a girl named 0. He also went on a date with a girl named 4. So this guy got matched up with 2 different Y values or 2 different girls. So therefore, this one is not a function. Okay, again, every X can only match up with one Y. Every guy can only go on a date with one girl. If I look at the next example over here, and again, every guy can only go on a date with one girl. Every X can only match up with one Y. My eyes go immediately to this guy named 2. He went on a date with a girl named 7, but he also went on a date with a girl named 20. So because this guy matched up with 2 Y values, now this is not a function. All right, E is the one problem that usually gives kids the most trouble because I always say every X can only match up with one Y, but the statement does not go in reverse. It does not mean every Y has to be with one X. So every guy can date one girl, but the girl can go on as many dates as she wants. So this example is really, really good. It's going to be the one that maybe gives you trouble. So if I look at it, -7 goes on a date with 5. -5 also goes on a date with 5. Now, that girl has gone on 2 dates, but that's okay. That's not our rule. Our rule is only the guys can go out with one girl. So our guys are -7, -5, 2, and 3. So these guys, otherwise known as the domain or the X values, can only go out on a date with one of the girls, which is your range. So 5, 5, -2, and 5. That is your range or your y values. So again, every guy can only go on a date with one girl. So let's double check this. -7. I don't see any other -7, so that guy only went on one date. Her name was 5. -5. There are no other -5s, so he only went on one date with that same girl, 5. 2. There's no other 2s, so he only went on one date with -2. 3. There's no more 3s, so that guy only went on one date with 5. Now that girl went on 3 dates, but that's okay. Girls can go on as many dates here. Ranges can match up with as many domains as they want, but the rule is only every X can match up with just one Y. Okay? Every X has to match up with one Y. So this one is considered a function. All right, our last example here. Now again, every X can only have one Y value. This is a graph, so we're going to use what's called the vertical line test. So if I could ever draw a vertical line, not horizontal line, it's called the vertical line test. So I'm going to quickly say, well, if I drew a vertical line right here, it would only hit once. If I drew one right here, once. I will never be able to draw a vertical line and hit twice. So therefore, yes, this relation is a function. All right, now the next thing we're going to learn today is called function notation. I have the definition highlighted over here in green. Function notation is a way of representing functions algebraically. The function notation, and this is pronounced f of x. It's got an f with a parentheses x in the middle, but we say that out loud, f of x. That means a function of x. And that indicates that the x is the independent variable. So, function notation, we're going to practice this real quick. Now, if I had the equation, and I'm going to start off right here in red, y equals 8x plus 15. That's the same example they have right there. What we know is that x is your independent variable and y is your dependent variable. All function notation does is it immediately lets you know which one is your independent and which one is your dependent. So if I zoom in right here, whatever is in the parentheses, that variable, x, and it's also right here, that is always your independent variable. So if I said, what's the independent? You would just look right here and say, hey, that's in the parentheses. X is my independent. The name of the function is pronounced f of x. Now, it doesn't always have to be f. So f of x, you could say g of x. Down here later, you see c of s. So f of x, this is the name of the function. Now, this only tells you your independent variable. That's all it does, is it lets you quickly look at it and say, hey, this one's my independent variable, and in fact it is a function because it says f of x or g of x or whatever. So function notation, we are just going to take out the y and plug in whatever variable there is, and I'm going to call this one f, and we use the variable x. So that is function notation. Now let me use another example real quickly. If I gave you the situation, let's see, cost equals $5 per ticket plus $10 or something like this. To write that in function notation, we would say the cost depends on the ticket equals 5t plus 10. Now again, these variables, t has to match. If I wrote c of x equals 5t plus 10, that would not be considered correct because my variables did not match up. I have an x here, but I have a t over here. So make sure you do not do that. And on your homework, I'm going to test whether or not you remember that, okay? So function notation, again, it just allows you to look at this and say, hey, t or tickets is my independent variable, cost would be my dependent, and this whole function is called c of t. All right, the next thing we're going to learn is whether our graphs have an absolute maximum or a minimum value. Now I have 6 examples here, and I'm going to start at the upper left hand corner. This is called a parabola because it looks like a U or an upside down U. Now what I'm looking for is, can I put my finger on either the highest point or the lowest point? Now because this one has arrows going up, that means it goes up forever and ever in both directions. So if I said I could put my finger on the highest point, that would be impossible because there is no highest point. It keeps going up and to the right forever and ever, and it goes up and to the left forever and ever. So if there is no maximum or highest point, I'm going to look and see if there's a lowest point. So I start right here, it's going down, 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 down. Right here's the lowest point, and then it starts increasing. So right here would be the minimum or the lowest point. So I could say that green dot right there is the absolute minimum. Now let's look over here at the next example. Again, it's going up and left forever and ever. It's going up and right forever and ever because of those arrows. It starts off going down, so that's decreasing, and then it stops, and then it's increasing back up. So we have no highest point, so no maximum, because it goes up forever and ever, but I can put my finger on the lowest point, which is right here. That is the minimum point. So I'm going to put a little green dot right there that says it does have an absolute minimum, and it's at that green dot. Now, if I look at this line right here, I'm looking for the highest point. Well, it keeps going up and to the right forever and ever, so I can never put my finger on the highest point because it's going to go forever and ever that direction. Well, let's see if it has a minimum. Well, it's going down and left forever and ever and ever. So on this one, I cannot put my finger on either the highest point or the lowest point, so this line does not have a maximum or a minimum. Let's go down here to this example. Now again, I'm looking for either the highest point or the lowest point, so I'm looking right here. Let's look for the lowest point. The lowest point says it's going down and left, but it's going down and left forever and ever and ever, so I cannot put my finger on the lowest point. And the same over here, it's going down and right forever and ever and ever, so I can't put my finger on the lowest point. But let's see if I can put my finger on the highest point. Well, it starts off right here, and it's increasing all the way up to this point right here, and then it's going back down, decreasing. So this point right here is, in fact, the highest point. So therefore, this graph has an absolute maximum or highest point, and it's where that green dot is. Now let's look at this line right here. Again, I cannot put my finger on the lowest point because it's going down and left forever and ever, going down and right forever and ever. But let's see if I can put my finger on the highest point. It starts right here on the left side. It is increasing all the way up until this point, and then it turns around and decreases all the way down. So the highest point, I can put my finger on it, and it is right here where this green dot is. Our last example, this is an exponential. If I said, let's put our finger on the lowest point, it looks like it's going down and right, and it's going down and right slightly, but it keeps going down and right, down and right, down and right, so I can never put my finger on the lowest point. And I know that might be hard for you to understand because it looks like it kind of levels off. We'll get to that more in depth later, but for right now, you guys are just going to have to trust me that this is going down and right, so I can never put my finger on the lowest point. So let's check and see if we can do the highest point. Up here, it looks like it's going up and to the left. Well, if it's going up and left, I can never put my finger on the highest point either. So this one does not have a maximum or a minimum. All right, the last thing we want to learn today is to be able to describe a graph as using words like increasing and decreasing. So if I look at graph A, I'm going to start always on the left. We read a graph just like we read a book. We go left to right. So this one starts off increasing, then it's increasing again, and then it looks like a straight line, so we would say it becomes constant. So graph A goes increasing, increasing, constant. Graph B starts off right here, and it goes up at a curve. That's an exponential, so it goes up and to the right, so that is increasing the entire time. Graph C, again, we start on the left. It starts off decreasing and then increasing. Graph D is decreasing only. When we start at the left and we go to the right, it is decreasing only. Graph B was increasing only. It never changed. It was only increasing the whole time. Graph D is only decreasing the whole time. Graph E is decreasing and then decreasing again. So we have a curved line and then we have a straight line, but either time it's decreasing. Now graph F starts off right here on the left. It starts off increasing, then we have our absolute maximum point, and then it goes to decreasing. Graph G starts off on the left. It is increasing, then constant, then increasing again. And graph H starts off decreasing only. It is only decreasing from left to right. So again, graph B is increasing only. Graph D is decreasing only. Graph H is decreasing only.